Hi everyone, in this video I'll be demonstrating SMS IO-Link control using CODESYS. First I'll start with the connections from the SMS to the PLC. Then I'll get into connecting the PLC directly to CODESYS. And finally I'll be creating a code that will allow me to control the movements of the SMS. So let's get started with the connections. Before making any hardware connections, we do have to take a look at the wiring diagrams for the SMS and the PLC so that we know exactly which connections are to be made. So here I have the wiring diagram for the SMS. At the bottom is the logic power cable, which is going to be connected to the PLC, and it has 8 wires. What it's telling us is that the white wire needs to be connected to the positive 24 volts, the green wire needs to be connected to the CQ, and the yellow wire needs to be connected to the 0 volts DC on the PLC. The rest of the wires can remain unconnected. Switching over to the CPXE4 IO-Link module on our PLC, the positive 24 volts white wire can be connected into the second slot. The CQ can be connected either in the 0 or the first slot, and the 0 volts DC can be connected in the fourth slot. So let's switch over to the hardware to make those connections. What I have here is the PLC, the SMS, and the power supply. Taking a look at the SMS, I have a power load connection, which is an M12 cable. The other end of that cable is these two wires here, this light blue and white wire, which is connected to the power supply. The PLC is also connected to the power supply by these black and dark blue wires. So basically when I'm ready to turn everything on, I'll take this connection to the power supply. I'll take the other end and plug it in so that I can supply power to the whole system. Now the other connection on the SMS is the logic power connection. The other end of that cable is actually what we're going to be connecting to the PLC. So now that I've exposed the wires, it looks something like this. I basically unscrewed this so that I can expose the wires. And if you recall on the wiring diagrams from earlier, I'm going to go ahead and connect the white, green, and yellow wires to the CPXE4 IO-Link module. So I'll go ahead and make those connections now. Now I've made all the connections, so the green wire is connected to the 0, the white wire connected to the 2, and the yellow wire connected to the 4, all in the CPXE4 IO-Link module. Now that that's done, I'm going to go ahead and supply power to the whole system. So I'm going to go ahead and plug it in. Now the LEDs are turning on. Okay, the SMS seems to be on. We have a yellow LED on the CQ. That basically means that we need to go ahead and reference the piston rod. We're going to go ahead and do that with the CODESYS. So that's fine for now. Now what I'm going to do is I'm going to take an Ethernet cable and I'm going to connect the PLC to my laptop. That way we can connect the PLC to CODESYS. So let's switch over to CODESYS now. I still have all of my hardware turned on, but now we're going to connect the PLC to CODESYS. So I have CODESYS open. I'm going to create a new project. We'll title it CODESYS IO-Link SMS. Hit OK. From here, I'm going to choose my version of the CPXE, which is 3.5.12. I'm going to be coding in ladder logic, so I'll press OK. And we'll give it a minute to open up. Okay, now that this menu is appearing, I'm going to double click on device. And I'm going to scan the network so that it can scan to see if the PLC is connected. Then I'll click on the CPXE CEC. Okay. Now that green light means that it was connected. And I'll go back to the left menu, click on CPXE system. So I double click that. I'll go down here to actual configuration and I'll scan that so that I can upload the configuration of my actual PLC, and I'll apply it. Okay, so that seems to be good. I'm going back to device and I'm going to locate PLC settings, and I'll change this option to enabled to so that it always updates my variables. Okay, now I'm going to log in just to make sure that the CPXE is connected and good. I should see some green symbols on the left of those. and I'll hit run. Green symbols mean good, so we're going to log out, and now I'm going to start coding. So I'm going to open up the PLC program. Before starting the code, I want to lay out exactly what I want the SMS to do. So first, I want it to start at the move in position. Then once the status in is true, it's going to move out and it's going to hold there for 5 seconds. After the 5 seconds is complete, it's going to move back in. And once the status in is true, it's going to move to the intermediate position. Once the intermediate status is true, it'll hold there for 1 second and then it will move out. And that will be the end of cycle 1. I want this to repeat for 3 cycles. So I'm going to complete the code, and then I'll be back to explain where I got the variables and addresses from, and I'll also go through the process of the code. Before going online, I do want to make sure that all of my positions are accurate on the SMS. So what I'm going to go ahead and do is under for IO link, I'm going to right click and I'll click on plug device. From here, I'm going to look at my SMS, which is an EPCE2B. Actually, I can see it right here, and I'm going to plug the device. Once I double clicked on it, under IO link parameter, I'm going to set this to specialist and go under parameter menu. And I'll go ahead and open control parameters, and I'm going to read the positions on my SMS. What might happen is the position of the start press or the end position or intermediate position might be the same. So for example here, intermediate position could have been set to say 20.77. That might happen if you're following along, and what's going to happen is it's going to get confused when following the process, because it's going to think that the start position and the intermediate position are the same. So you can go ahead and come to this page if you want to just make sure that all of your positions are set okay, and you're going to write that if you had to edit anything. So we'll give that a moment to write. Mine was already at 10, but it's always good to check. So once that's done, I'm going to log in. It might give you a signal to log in with the download, but what I'm going to do is I'm going to run my program. And if you recall, when we were doing the wiring configuration, our CQ LED was actually a yellow color. So in order to reference that on CODESYS, I'm going to, now that it's running, I'm going to set this to true. And I'm going to hit Control F7 on my keyboard so that I can move the actuator out, and that way it knows that it's referenced. So my CQ should now turn green once my actuator moves. So I'll hit Control F7. Actually, it might have been my move out. I moved my move in, which it was already at move in position. So I'll change HMI move out to true, and it went ahead and moved out. So I'm going to stop this here. and do a reset warm, because I do want to show you, once the process is running, I want to show you the counter actually increasing in value, and I do want to show you the timer running as well. So I'm going to run this again, and I'm going to start from the beginning. So I'll set this to true, and it's going to go ahead and start. I'll show you on the actual hardware in a moment, but I want to show you the timer moving as well as the current value increasing down here. So we're at the second cycle. Now we're at the third cycle. And then it reset again. Now, in order for us to make sure that it doesn't reset, we would have to go ahead and set the HMI move out. We would have to stop that button. So if I do an online reset warm, I'm going to run it again. And here I'm going to set this to true. So it's starting again. You can see the timer running. You can see the current value increasing. I'm going to take this off of true. That way the process doesn't start again. So we're on the second cycle. Now that we're on the third cycle, that should be the last one, and everything should reset. And we are. So now you see the timer's not running anymore, and everything worked out. Now that my code is complete, I'm going to explain the variables as well as the process of the code. So starting at the top, I have the move in, move out, and intermediate positions, which are all outputs. I also have the status of all of these positions. So basically, I want to know whether the actuator has officially reached the position. That way we can proceed with the following code. I also have the HMI move in and move out variables, which are Boolean variables. These are basically triggers for when the process should start or stop. And the rest of this will come with the rest of my code. So I'll go ahead and explain the ladder logic, starting with rung 1. So I created a sequence for my code. You can basically think of these as steps. So we're at step 0. Once it completes all of this code, we're going to end up at step 10. And rung 2 cannot start until step 10 is true, and that'll follow through the rest of the code. So starting with rung 1, I'm telling the process to go ahead and start. So the actuator is going to immediately move out. Once status out is true, it's going to hold there for 5 seconds. And I created a control variable here. Once those 5 seconds are complete, it's going to move in, and it's going to reset the move out position. From there, it's going to reset the control variable as well as the move in position, and it'll immediately move to the intermediate position. Once the status intermediate is true, it's going to hold there for 1 second. And I created another control variable. From there, it's going to immediately move out and reset the intermediate position. And that's basically the end of the first cycle. So we reset the control variable, the intermediate position, and set the move out position. If you recall, I would like to repeat this cycle 3 times. So I implemented a counter here. My preset value is set to 3 for the 3 cycles. And basically what I'm saying here is if we have reached those 3 cycles, then complete a process. And if we have not reached those 3 cycles, then go back and start again. So for example, if the current value is anything less than 3, then I would like it to go back to step 10 and complete the process again, and then it's going to check again. However, if the current value is equal to the preset value, which is 3, it's going to move to step 80. And in step 80, I'm basically resetting everything, saying that the process is complete. And that's the end of my code. I hope you enjoyed this video. I hope it was helpful, and I'll see you on the next video.